Hello everyone. So kule video discuss question paper le physics siyenza question related ne momentum and impulse. So question paper ngiliqalile I supplementary exam yaka 2010, and then ngithe senza question 4 it's a equation here, momentum and impulse. And then lapha, okay, ngaphandle kokuthi simoshe isikhathi, let us do question 4. So lapha bathi, during an investigation, a police officer fires a bullet of mass 15 grams into a stationary wooden block of mass 5 kg suspended from a long strong cord. The bullet remains stuck in the block, and the block bullet system swings to a height of 15 centimeters above the equilibrium position as shown below, right? The effects of friction and mass of the cord may be ignored. And then but state the law of conservation of momentum in words, right? Remember when we started ngithe definitions lawa kumele wazi from exam guidelines. So nabathi state the principle of the law of conservation of momentum. Just write the definition le kuma exam guidelines. So you would say the total linear momentum in a closed system is conserved, or the total linear momentum in an isolated system remains constant, right? Just make sure you know your definitions. Okay, that is 4.1 is just a definition of the law of conservation of momentum. And then question 2, but use energy principles to show that the magnitude of the velocity of the block bullet system is 1.71 meters per second immediately after the bullet struck the block. So but use energy principles. So the question ngithena ngicala ngabona ukuthi it's more related to physics yaka grade 10 than it is to physics yaka grade 12. So I think if you can still remember from grade 10, you would know ukuthi the kinetic energy and potential energy are sort of like related, ne? And then nasiya ku formula sheet yethu, right at the end you would see energy principles. They have their own set of equations, right? So there, this is the formula for a kinetic energy is 1 over 2 mv squared, and then this is the formula for the potential energy, the gravitational potential energy. So remember, Nas Thomas define a kinetic energy ukuthi it's an energy that an object has because of its motion or movement. And then the potential energy define, this is an energy an object possesses because of its position in relation to other object that it interacts with, right? And then now gravitational potential energy, this one is the gravitational potential energy because lapha kune gravitational acceleration uG. The gravitational potential energy will then be the energy that an object has because of its position above the surface of the earth, because we also have height there. The height is measured in meters, right? So the way we would answer this question is to say a gravitational potential energy. Okay, ngizoya question 2, sorry, 4.1 already. Define law of conservation of momentum, right? And then question 2, we use energy principles to show that the magnitude of the velocity of the block bullet system is 1.71 meters per second. Okay. Okay, so our question to Bati, use energy principles to show that the magnitude of the velocity of the block bullet system is 1.71 meters per second immediately after the bullet struck the block. Okay. So from physics grade 10, you would remember what kinetic energy and gravitational potential energy, they were sort of like related in this equation of saying the total energy at the bottom will be equals to the total energy at the top, right? Right, so this is that energy principle. Ne? The total energy at the bottom will be equals to the total energy at the top. So now we know what the kinetic energy is the energy of the is an energy that an object possesses because of its motion, right? And then we know what a formula a kinetic energy is this one, ek is equals to 1 over 2 mv squared. And then the formula a potential energy is mgh, where m is the mass, g is the gravitational acceleration, h is the height. And then now at the bottom we want to calculate the speed of the block bullet system immediately after the bullet collides with the block, right? So when they collide, the masses will be joined. We'll have the mass of the bullet plus the mass of the block, né? for the portion of the kinetic energy, right, times v squared, which is what we want to solve. And then the kinetic energy, because at the bottom the height is 0 there, the potential energy, because at the bottom the height is 0, our potential energy will be 0, right? And then now we are at the top, because at the top the velocity is sort of like 0. As the bullet struck the block bullet system will move to this height and remain at rest for a couple of seconds. As they remain at rest, the velocity of the block bullet system at that point in time will be 0. Because the velocity is 0, it means the kinetic energy will be 0, right? So the kinetic energy at the top will be 0. Now we'll have the potential energy of the block bullet system, right? So it's the mass of the bullet plus the mass of the block times the gravitational acceleration times the height. Now let us substitute. We have 1 over 2. The mass of the bullet is 15 grams. So in kilograms it will be 0.015, right? When you divide 15 or 1000, and then the mass of the block is 5 kg times v squared, which is what we want to solve. And then same thing nangapha, the mass of the bullet is 0.015, the mass of the block is 5, the gravitational acceleration is 9.8, and then the height is 15 centimeters. In meters it will be 0.15. right? So now on the left hand side sizoba no 2.5075 v squared, and then on the right hand side we will have 7.37205. and then now solving for uv, we'll have that v is equals to the square root of 7.37205 divided by 2.5075 is equals to 1.71 meters per second to the right. So that is how we solve this question. The key to solving this question was to remember that using energy principle, the total energy at the bottom will be equals to the total energy at the top, right? And then you know what is the total energy we're talking about: kinetic energy and gravitational potential energy. Okay, so now let us go to 4.3. So 4.3 uti calculate the magnitude of the velocity of the bullet just before it struck the block. So 4.1 we were asked to define the law of conservation of momentum. So now 4.3 is to apply this law of conservation of momentum, right? Now from this question they tell us the effects of friction and mass of the cord may be ignored. So now it means because we're ignoring friction, we don't have external forces. So if we don't have external forces, it means we can now apply the law of conservation of momentum, which states that the total linear momentum in a closed system is conserved. Because we have no external forces, we have a closed system, right? So now applying the law of conservation of momentum, we know that in a closed system, the total linear momentum before collision is equals to the total linear momentum after collision, right? That is, the total linear momentum before collision is equals to the total linear momentum after collision. So now the total linear momentum before collision will be the momentum of the bullet plus the momentum of the block, and then the total linear momentum after collision will be the total linear momentum of the block bullet system. So we'll have B plus capital P, because the bullet and the block are now one system, right? So now here we have the momentum of the bullet. So the momentum of the bullet will be the mass of the bullet times the velocity of the bullet before collision, right? And then here we have the momentum of the block. So the momentum of the block will be the mass of the block times the velocity of the block before collision. Now here we will have the mass of the bullet and the mass of the block combined, because now they are one system, times the velocity of the entire system, right? So now before collision, the mass of the bullet is still 0.015 grams, and the velocity of the bullet is what we want to solve, right? And then the mass of the block is 5 kg, but then the block is at rest, so its velocity is 0 there. So here we will have 0, right? And then after collision, the mass of the bullet is combined with the mass of the block, because now they become one thing, they become a block bullet system. So we'll have the mass of the bullet and the mass of the block times the velocity of the system after collision. So this will be the 1.71 that we solve for 4.2. So this will be 1.71, right? And then now we can solve for the velocity of the bullet. So the velocity of the bullet will be 5.015 times 1.71 divided by 0.015, right? And then when you punch this in your calculator, uzothola ukuthi the mass of the velocity of the bullet is equals to 571.71 meters per second to the right. So yeah, that is the velocity of the bullet before it strikes the block. Okay, so lapha 4.4, but the police officer is pushed slightly backwards by the butt of the rifle which he is holding against his shoulders while firing the rifle. Use the relevant law of motion to explain why this happens. So now if you look at this question, this is the application of Newton's third law of motion. Newton's third law of motion, if you check from the exam guidelines or the definition in your textbook, for every action there is an equal opposite reaction, right? So here in this situation, as the police officer fires the gun will exert a force on the bullet, right? And then the bullet will also exert a force in the opposite direction to the gun, right? And then the force that is exerted on the gun will be transferred to the police officer, right? So according to Newton's third law of motion, the gun will exert a force on the bullet, and the bullet will exert an equal force in the opposite direction on the gun, right? The force that is exerted on the gun will now be exerted on the police office. So now if we try to draw a situation, okay, so let us say this is the gun, right? This is the gun, right? And then here we'll have the police officer holding the gun, right? As he pulls the trigger, the gun will exert a force on the bullet, and then the bullet will sort of come out. Now the bullet will exert an equal force in the opposite direction to the gun, right? Now the gun will sort of move backwards. The force that is exerted on the gun will be transferred to this police officer, and therefore he will be pushed back by that force. Okay, I hope it makes sense. So with a free body diagram, it will look like this. This is the force that the gun exerts on the bullet, and then this will be the force that the bullet exerts on the gun. Now this force will then be transferred to the police officer here, and therefore he will move backward slightly. Okay, I hope it makes sense. So yeah, we've come to the end of the question. Hopefully you will understand indlela engichaze ngayo. If still you don't understand, feel free ukuthi ungibuze ngizama ukuthi ngichaze ngcono. Okay.